So this first one says, if f of x equals x times sine of 2x, which of the following is the Taylor series for f about 0? So it's the sine of x function, except we're replacing x with 2x, and then we're going to multiply the whole thing by x. So again, I'm not going to keep pulling that paper out, like, put it here and then take it off again. I don't want to make you seasick putting that under the projector again and again. So I'm just going to go ahead and write it out. Sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Again, it's the one that has all the odd numbers in it. So if you want to remember it that way. So I'm just going to write that out, and then we're going to do the transformations that have happened. So everywhere there's an x, we're going to replace it with 2x, and then we'll multiply it by another x. So for this first term, if we replace x with 2x, that would just be 2x, and then multiply by another x, that's going to be 2x squared for the first term. All right, and then here, if we replace x with 2x, 2 cubed would be 8, so we're going to have 8x cubed, and then we would multiply by another x. So it would be 8x to the 4th over 3 factorial. And then again, replacing x with 2x. So 2 to the 5th is going to be 32. So we'll have 32x to the 5th, and then the other x is going to make it x to the 6th. So 32x to the 6th over 5 factorial. Can we pick our answer at this point? Or do I have to go one further? Let me see. It's either D or E. Yeah, you know what? We can narrow it down at this point. So you can keep going if you want to. But E is going to have to be the answer here. That's the one that matches so far. So E for that one. I'm not telling you to be lazy, but the AP exam is timed. So once you get to the point where you can pick your answer, you want to stop and just go ahead and pick that and move on to the next problem. All right, so this one's kind of backwards. Instead of being given the transformed function, we're given the terms in it, and then we have to figure out which function it is. So when I'm looking at the denominators here, I see 2 factorial, 3 factorial, 4 factorial. So it's not going to be sine or cosine. E to the x is the one that has all of them. So let me just write out e to the x for us real quick. 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial. This one doesn't skip any, so it's got all of them. All right, so that's e to the x. So I know it's going to match up with that because I see the 2 factorial, 3 factorial, 4 factorial here. So anything with like a sine or cosine, we can kind of get rid of. So I can narrow it down to these two. And it looks like when I see this 2 factorial here, the numerator, instead of x squared, it's x to the 4th. So when I'm looking to match up that term, instead of x squared, it's x to the 4th. So it looks like we multiplied by an x squared here. So I'm going to do that next. Multiply each term by an x squared. So that will give me x squared plus x to the 3rd plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial plus x to the 6th over 4 factorial. And so these terms match up with these right here. So we just need to get rid of these two. And so we're just subtracting those off. So we have to subtract off the x squared and the x cubed, which is what's going on in this choice here. And like I said, you can kind of use the choices to help you, like sort of look at what they have here and try to get it to match up. So that one is D. All right, so this one says, what is the coefficient for x squared in the Taylor series for this function around x equals 0? So I won't write out the whole thing like I've been doing. I'm just going to jump to the x squared term. It would be the second derivative at 0 over 2 factorial. That's what will be in front of, you can put the x squared here if you want, but all they asked for was the coefficient. So it's just going to be this. So we're going to need to get the second derivative of this function and then plug in 0. So let me actually just rewrite the function real quick. This would be 1 plus x to the negative 2. So that's the function that we have. And I need to get to the second derivative. So first derivative, I'm going to bring down the negative 2. It's going to drop to a negative 3. And then there would be a chain rule, but the derivative of this inside stuff is just 1. So you can put times 1, if you want. And then second derivative is going to be 6, 1 plus x to the negative fourth. And so I'm just going to rewrite that 6 over 1 plus x to the fourth. So this is our second derivative here. So we want to plug in 0 to that and then put it over 2 factorial. So if we plug in 0 here, this denominator is just going to be 1. So that's just going to be 6 and then over 2 factorial, which is 2. That would be 2 times 1, which is 2. So 6 divided by 2 gives you 3. So that one is D. All right, a series expansion of sine of t over t. So I just use t's instead of x's, but here I'll go ahead and write out sine of x again, but I'll write it with the t's here. So it'll be t minus t cubed over 3 factorial plus t to the 5th over 5 factorial. I almost wrote an x there. Minus t to the 7th over 7 factorial, and on and on. So what we've done with that is we're going to go through and just divide every term by t. So if I divide every term by t, this would just be 1 minus, and then this would be t squared over 3 factorial plus t to the 4th over 5 factorial minus t to the 6th over 7 factorial. And that's probably far enough. In fact, I probably didn't even need to go that far. Let me see which one is it going to match here. Is that A for that one? Yeah. So 4 is A. All right, the coefficient of x to the 6th in the Taylor series expansion around 0 for f of x equals sine of x squared. So once again, I wish this had landed on the same side of the paper, and I wouldn't have to be, rewriting this again here. But I'm going to write this out one more time. There's nothing wrong with rewriting it. That's what helps you to memorize it anyway. So we're going to replace every term with x, or replace every x with x squared. So this term would just be x squared, and this would be minus x squared cubed. So that'd be x to the 6th over 3 factorial. And actually, I'm going to go ahead and stop there. You can keep going if you want, but I was asked, what is the coefficient for the x to the 6th term? And this is my coefficient. So negative 1 over 3 factorial. 3 factorial would be 3 times 2 times 1, which is 6. So negative 1/6. And so that one is A. So I wrote out what sine of x was. I replaced each term with x squared, and then we were looking for the coefficient with the x to the 6th term. And then last one, what is the sum of this series? So they didn't write out very many terms here for you, but this next one would be ln of 2 to the 3rd over 3 factorial, and then you would have ln of 2 to the 4th over 4 factorial. So you have all the factorials in here, 2 factorial, 3 factorial, 4 factorial. So this one is going to be e to the x. And so let me just write out a few terms of that one. And so what they've done is they've plugged in ln of 2 for x. So what they've done is e to the power ln of 2. So everywhere there's an x, they plugged in ln of 2. So that's what this is going to all equal. And e and ln cancel out. And so that's just going to end up being 2. So that one is C. Let me hit pause here.